So once again, your quest for this unit will now be on October the 19th or 20th. All right, it wouldn't be tomorrow. It wouldn't be on Friday. It will be on Monday or Tuesday, October the 19th or 20th. So here comes the last lesson in this chapter: parallel lines and perpendicular lines. At this point, you probably know what are parallel lines and how do they look like. And probably same thing for perpendicular. When you are working with parallel lines, you are looking at things that go this way. Two lines that will go in the same angle. These are what we call parallel lines. They will never touch each other. Doesn't matter how long you extend your line, here or there, they will never touch each other. This is what we call parallel. When it comes to perpendicular lines, you are looking at lines that will create a 90 degree. So if I have a line going this way, a line that is perpendicular to this one, may go this way, making a 90 degree between the two of them. So these are what we call perpendicular lines. When it comes to parallel and perpendicular lines, their slope will have some special properties. And here in example number 1, we are going to use these two examples to identify the relationship on the slope between these two lines. Example number 1. The first line we have y equals 2x plus 3. We have slope equals 2 and y-intercept equals 3. We are going to see a line starting from the y-axis at positive 3. Here is where you'll be starting at. And the slope of the line is positive 2. It is going to go up by 2 units and run by 1. So here is a second point. Here is one more. And it will go in with the same pattern, going up or going down. These points will now give us a line. The first line will go up in this way. Second equation, they have it in general form. I can rearrange the term and come up with the slope and the y-intercept by changing it back into y equals mx plus b. Seeing how we have a negative y in this equation. If I'm to bring it to the other side, I will end up getting a positive y on one side, and the rest of it will stay on the left-hand side. This is the equation in slope-intercept form. The second line in this case gives us negative 4 for the y-intercept and positive 2 for the slope. Let me make this smaller. Negative 4 for the y-intercept and positive 2 for the slope. So in this case, we have two parallel lines. How are the slopes related to each other in this case? thing. They have the same slope. We have m equals 2 for line number 1, and we have m equals 2 for line number 2. When it comes to parallel lines, their slope will be the same. Or in another word, m1 equals m2. The slope of the first line and the slope of the second line are equal to each other. But when it comes to perpendicular line, it won't give us the same slope anymore. The slope will be a little bit different. So for the second one, 2x plus 3y equals 5. If I'm to draw the line for this equation, I can rearrange the term like what we did in the previous case. Single out the y and keep it on the left hand side. We will now end up with a negative slope in this case. Negative 2 over 3. This line is to go downhill, starting from the y-axis at 5 over 3. Or technically, 1.6 repeating. If you are not too sure where is 1.6 on your graph, if you are not 100% sure that this will be the point on the y-axis, you can set up a table of value to draw this line instead. You can use x equals 1, x equals 2, x equals 3, and so on. And you are going to find a nice point to start your line. You don't have to start your line from the y-axis. It works when we have a nice value, like in the previous example. We have positive 3 or negative 4. We can find the point on the y-axis easily. But when we end up with 1.6, like a decimal value, you probably want to try out different numbers and see if you can come up with a nice value. Like let's say, if I use x equals 1, when x equals 1, you will have x equals 1 here, and that turns into negative 2 times 1 plus 5. Giving us positive 3. So if you have 3y, equals 3, we will have y equals 1. We will have y equals 1. That's one point on your graph. And you can start from this point, create a line that goes downhill with slope negative 2 over 3. Down by 2, run by 3. Giving us the line here. Using the same concept, I can come up with the slope for the second equation. With 3x minus 2y equals 1, I can rearrange the term single out the y and divide the negative 2 to the other side. This time we have a positive slope, 3 over 2. The y-intercept is at negative 1 over 2, negative 0.5. Starting from this point on the y-axis, it is moving up by 3 and run by 2. Up by 3 and run by 2. Now you will see a line that will go through the first one with a right angle. This is what we call perpendicular. When it comes to perpendicular lines, their slope will be somewhat related, but somehow they are not the same. What do you see in this case? What happened to their slope? Sebastian? One is negative, one is positive. The sign will be opposite. What about the numbers? They also flip, yes. The first one gives us 2 over 3, and the second slope gives us 3 over 2. So we have opposite sign, and the numbers will also be flipped. This is what we call negative reciprocal. When we are working with perpendicular lines, their slope, oops, so when it comes to perpendicular line, their slope the first slope and the second slope will have opposite sign, and then you ought to flip the numbers at the same time. We call it negative reciprocal slope. If you don't like the relationship given in this equation, a still easier way to interpret that is to multiply the first slope by the second slope. When you multiply these two slopes together, they will give us negative 1 as a result. So this is what happens when two lines have perpendicular slope. So make sure you understand the concept here.